Hi everyone, today's topic is metal shadowing and scanning electron microscope. Next, what is SEM? Scanning electron microscope is a type of electron microscope capable of producing high resolution images of a sample surface. Some images have a characteristic three-dimensional appearance and are useful for judging the surface structure of the sample. Wall system must be vacuum protected to prevent scattering of the electrons by stray air molecules, and the specimen must absorb or reflect electrons. Samples have to be prepared carefully to withstand the vacuum inside the microscope. This is a picture showing the parts of SEM. The principle behind the SEM utilizes focused beam of electron to obtain the information. This electron interact with the sample, producing various signals that can be used to obtain the information about the surface topography and composition. The signals as detected by appropriate detectors. Next is the working of SEM. SEM consists of the virtual source at the top represent the electron gun, producing a stream of monochromatic electrons. The stream is then condensed by the first condenser lens. The lens is used to both form the beam and limit the amount of current in the beam. It works in conjunction with the condenser aperture to eliminate the high angle electrons from the beam. The second condenser lens forms the electrons into a thin, tight, coherent beam is usually controlled by the fine probe current knob. A user-selectable objective aperture further eliminates high-angle electrons from the beam. A set of coils then scan or sweep the beam in a grid fashion, dwelling on points for a period of time determined by the scan speed. The final lens, the objective, focuses the scanning beam onto the part of the specimen desired. When the beam strikes the sample, interactions occur inside the sample and are detected with various instruments. Applications of SEM: thickness of films and thin coatings, surface morphology and appearance, shape and dispersion of particles, fibers, nanomaterials, or any other additives in composites and blends, height and lateral dimensions of nanometer sized materials, cell size and size distribution in foam materials, chemical composition and element analysis of nano and micromaterials, fracture and structural defect analysis. SEM has been utilized to study the surface morphology of nanomaterials and nanoparticles. Metal shadowing. Metal shadowing is a technique where to visualize the surface of isolated subcellular structure or macromolecules in the transmission electron microscope. The specimen is coated with a thin layer of evaporated metal such as platinum. The metal is sprayed onto the specimen from an angle so that surfaces of specimen that face the source of evaporated metal molecules are coated more heavily than others. These differential coatings create a shadow effect, giving the specimen a three-dimensional appearance in electron micrograph. Electron micrograph of actin or myosin filaments of the cytoskeleton prepared by metal shadowing. Thank you.